All right, hi 20-1 students. So today we are moving on to lesson 2.3. So if you remember last time we were looking at 2.2, which I divided into two sections, and we were looking at trig ratios of any angle. So the last few sections we've done, I guess everything we've done up until now, if we look back to our original page here, we've been looking at angles in standard position, trig ratios of any angle, so we've been dealing with things that are in coordinate planes, even if we're using a triangle to solve for them. But today we're going to move on to something a little bit different, where we're just using triangles and we're moving away from that kind of like coordinate plane system. And we're going to be looking at solving triangles that do not have right angles in them. Okay, so remember that with trig, we're using that for any angle that, or any triangle, I guess, that has a right angle as a component. And now we want to look at how can we solve triangles that don't have that right angle. So, yeah, and that's kind of what's summarized here, right? Is that before you could use Pythagorean theorem or trig in order to solve for 90-degree angles. But we're going to be looking at, there's lots of problems obviously in math that do not involve a right triangle. So they involve something called an oblique triangle, which is any triangle that doesn't contain a right angle. And so one of the ways that we can solve these type of triangles is using something called the sine law. So let's get a look at what that is. So the ratios of angles and opposite sides are equivalent. Oh, look at that little typo there. Equivalent for all three side angle pairs in an oblique triangle. So just like we saw, ratios between like sides and angles when we're looking at sine, cosine, and trig, we have these kind of ratios in oblique triangles as well. They just don't follow the same rules. And so just keep in mind, oblique always means a triangle with no 90-degree angles. So one of the first things we want to be able to do with sine law is identify these opposite sides and angles. So just like the word implies, we're always looking at opposites. So if you look at this triangle here, if we label this angle here as angle C, so remember angles are always identified with a capital letter, then straight across from that is going to be the opposite side, just like when we're looking at opposite sides in trig ratios, right? It's straight across from the angle that we're working with. So basically if you go straight across, then you're going to find the opposite side, which will be identified by the same letter but in lowercase. Okay, so same thing here. If we have side B here, which is lowercase, if we go straight across from it, we're going to find angle B. Okay, and then last of all, if we have side A or angle A here, we're going to go straight across to find side A. Whoops, that wasn't a very straight line. Oh well. So yeah, you get the general point. So what the sine law does is it looks at these ratios and it sets them as equivalent to each other. And we'll look at why that is in a minute. But basically, just to introduce you, the sine law is saying, there's kind of two versions of it. So we could start out by saying sine of angle A divided by the side that's opposite it. The ratio between those two is going to be equal to the ratio of sine of angle B divided by side B, so the opposite side. And we can also say that that's like either one of these would be equal to sine of angle C, you could probably guess that was coming, over side C. Okay. Now, alternatively, we can flip this whole thing, and the only reason we would do that is sometimes it makes the algebra a little bit easier for rearranging if you're solving for unknowns. There's not really any other reason why you need to flip it, and I believe, let me just have a look on our formula sheet here. Oh no, you are actually given, so you're given both versions on your formula sheet, and so basically the inverse of this would also be true. So side A divided by sine of angle A is going to be equal to side B divided by sine of angle B, which would also be equal to side C divided by sine of C. So when you're solving problems with the sine law, you're never going to be using all three of these together, but you can pick and choose whichever ones you have. So like this one is going to be equal to this one, or this one and this one. So it's all going to depend on what information you're given. And we'll go over some examples so that that becomes clear. So in the first example, the thing we want to do is actually understand why does the sine law exist, and how can we prove that that would be an accurate, or that it's true, basically. So the way we can do that is by taking an oblique triangle and using our normal trig ratios to solve for these different sides and angles to determine if the sine law is accurate. And the only way we can do that, of course, is to divide this oblique triangle into two right triangles so that we can use those trig ratios we're familiar with. So let's break this up into two triangles. So we've got this triangle here, and then we have this triangle here. Oops, there we go. It's a little messy, but whatever. So the only thing that we'll have to add in, though, because we only have angles for the triangle and they're only for the oblique. So if we have LMN, let's make this K. So this angle here, this 90 degree, is going to be angle KL. Yeah. Well, we're going to have two triangles, KLN or KLM. And so the other thing we need to have is a side for this one. So let's just call that one X to keep it, because it's not really part of this whole triangle here. And then identify the sides here. So straight across from angle M, if we go straight across, we find side little m. Angle N here, if we go straight across, we get side little n. And angle L, if we go straight across from there, we get side little l. Okay, so let's first of all look at angle KLM. Okay, so, triangle KLM. Okay, so that's our pink triangle. So if we want to set up a trig ratio, the angle we would be looking at is right here. And because we're dealing with sine law, we just want to look at the sine functions for both of these triangles. So remember that if this is our reference angle, sine is going to involve the opposite side, which will be x, and our hypotenuse, which will be n. So we can say sine of angle M is going to be equal to opposite, which is x, over hypotenuse, which is n. Okay, now if we want to basically set this up to solve for our unknown value, which is x, we would rearrange by multiplying n across to the other side. Well, multiplying it by both sides, but that moves it over. So then we can say x is equal to sine m times by side n. Okay, so this is our first thing that we're going to work with here. The next one we want to look at is the other triangle that we built up here. So KLN, and that's our blue triangle. And so basically what I would do here is say same thing, right? So I come up with my angle N, and I'm going to set up my sine ratio as well. So sine of N is equal to the opposite side, which again is x, divided by my hypotenuse, which in this case is m. And then again, I just want to isolate x, right? So that means I'm going to multiply m by both sides, which will remove it from this side and make it sine of n multiplied by m is what x is equal to. So now I have two things that I can say x is equal to, and x is the same, right? We have the same variable, it's the same side, but they're equal to two different things. Now, there's something called the transitive property in math, which means that if x is equal to this and this, then these two also have to be equal. So basically what I can say then is sine m times by n is equal to sine n times by m. Okay, so this is showing some of the equivalency, but basically what we want to do is to set it up in the same way that we see it in the sine law. We want to have these as fractions. And so basically what we want to do is divide out both of these multipliers, these sides. You could do either way, like you could choose to do both the angles or you could do both the sides. But in the textbook, they show you the example of how to do it with the angles. So in this case, we'll do it with the sides. So basically, if you want to eliminate these multipliers on the top, remember that means you have to divide both of them out of each side. So we have to divide this side by nm and this side by nm, right? So in this case, we're going to have n divides out so that we're left with m on its own. And in this case, m divides out, so we're left with n on its own. And so now you can actually see the sine law already there, which is that sine m over side m is equal to sine n over side n. And that's our sine law. So you can see how we can prove that the relationship between these angles and sides exists by breaking it down into right triangles. Okay. Let's see. So let's go through some other examples now that we can kind of be sure that the sine law is actually a true thing. So the first one asks us to sketch a triangle that corresponds to the equation below. So we're given a sine law equation, right? Sine of an angle divided by a side is equal to sine of another angle divided by a given side. And then we want to solve for the unknown side length. So in this case, that's W. And then round to the nearest one decimal place. So I've already drawn this triangle. You don't have to be super careful with drawing, but I just wanted to have it set up beforehand. So if you did want to draw a triangle kind of like to scale, I just drew my straight line and then I used my protractor to make a 50-degree angle and then go to the other side and make a 60-degree angle. Okay, but you don't have to be that precise. I just find that I like it because then at the end, if I know my triangle is drawn to scale in terms of angles, I can kind of look and see if I think that my final answer seems somewhat accurate. So with labeling a triangle, you want to always think about what are the essentials that you need. So in this case, because we're given the sine law to begin with, we can kind of start with that. So we're going to have to make sure that on this triangle we've labeled angle sine 50. Okay, and the side that corresponds with that is the unknown W. So we're going to label those and they're going to be across from each other. So if this is our 50-degree angle, the side that goes across from it is going to have to be W. Then we also wanted to have sine 60. Okay, and we already put that in there. So now the side across from it, because remember in the sine law, the angle has to correspond with the opposite side. So going straight across from there, we must have a side with a length of 8, and it doesn't give us the unit, so we'll just leave it as 8. So that's our other thing that we had to label in there. Now we can go ahead and start trying to solve for our unknown variable, which in this case is W. So I'll talk a little bit more about this in a minute when we can set up our own sine equation. Usually if you're looking for an unknown side and you have the option to set up your own sine law, you want to use the second version where so if the unknown is a side instead of an angle, use this version that has the side on the top, only because it just makes your algebra a little bit simpler, not because one answer will be right and the other will be wrong. Like you can use either one of these, but it just makes your algebra a little bit easier if you do this on top. But this is a little bit of a challenge question to test our algebra skills, so we'll follow through with this one to begin with. So there's multiple ways of doing this. Some of you might be familiar with cross multiplication, which is I don't love because it takes away like the idea of understanding how algebra works. But if you're already comfortable with algebra, you can use the cross multiplication method, but I won't go over that right now. So the other option you can do is just basic straightforward algebra where you would just move like this W and the other items until W is isolated. Or we can do, this is the third method, which I've already shown you guys in quite a few different instances how to do that second method I was talking about of just moving the w. So in this third one, we're going to talk about rationalizing the denominator. And so in that case, basically what we want to do is multiply both sides by the denominators that we see in these two separate fractions. And that will just kind of like help to skip a step. So basically I want to remove the w and the 8 so that I'm free of fractions. And so I'm going to multiply this side by w times by 8. I'm not going to write in the decimal, guys, for now, just because we know it's 8.0. W times by 8. It's just going to save me some writing. So when I multiply this out, 8 divided by 8 is going to cancel out, and w divided by w is going to cancel out. So remember, your whole value that's multiplied is always going to go through the top of the denominator, or top of the fraction, sorry. So I'm going to have 8 times by sine 50 is equal to sine 60 times by w. Okay, so now all I want to do is move this 60 away. Okay, so I'm going to divide that out. Sine 60. You would have gotten this if you used the second method too and just multiplied the w away. Sine 60 cancels out, and we are left with w is equal to 8 times by sine 50 divided by sine 60. Now this is another instance where I want you guys to try this in your calculator to make sure you get the proper number value so that you know how to use your calculator for order of operations, so that if you're on a test, you don't get an incorrect number because you were not familiar with how to do order of operations. So put this in your calculator, make sure you get 7.1. If you don't, go back and make sure that you've done your brackets properly. So like I would even put that into brackets if you're going to do this all in one string. Usually what I would do is 8 times by bracket sine 50 bracket, and then I would hit enter, and then I would just go divide that by sine 60 in brackets. So yeah, now we're left with w is equal to 7.1. And if we look at this triangle, if the side is 8, it seems rational that that would be 7.1. Even without looking at it, right? If we have a side length of 8 and our angles are pretty close, remember an equilateral triangle we talked about is 3 angles of 60, but that would be with equal sides. So this does make sense that it would be 7.1 because we have a little bit of a bigger angle here. So they're going to be a little bit offset from each other, but we still expect the side lengths to be within a reasonable closeness to each other in terms of how they measure. Okay, let's look at another example here really quickly. So with this one, we're given our triangle and we're asked to determine the length of b to the nearest tenth of a centimeter. So again, make sure you identify your sides that go together. So we have, in terms of angles, we have sine b, which is sine of 72 degrees. Aside across from angle B. So when we set up our sine ratio, that means we want to make sure that we pair those together. Like I told you guys, if a side is the thing that's missing, what you might want to do is make sure that you use the version of the Sine Law that has the unknown side on top. So we're going to do B divided by sine 72 is equal to, and then the other information we were given here is 43 degrees. So you always want to look for what information you have across from each other. So 43 degrees. So sine of 43 is straight across from 27.2 as a side length. Okay, and so now I'm going to say 27.2 is my side length, so I'll put that on top, divided by sine of 43 degrees. Okay, now the thing that makes it easier to have this side length on top is all I have to do is multiply this across, and then I'm done, right? So I'm going to multiply both sides by sine 72, and these are going to cancel out, and I'm going to left with b is equal to 27.2, and remember, when you multiply a fraction, it's going to multiply straight across, so times by sine 72, and then divide that all by sine 43. Again, please try this in your calculator to make sure you have order of operations down, but you should end up with B being equal to 37.9 centimeters, okay? Equals B. Okay. Okay, let's try example 4. Okay, so with example 4, we're looking for an unknown angle in this case. So the unknown angle is theta, which is angle C. Okay, so we're looking for, in terms of angle, we want sine C, and the side that's across from that is 37.1. Okay, so because we have an unknown angle, this time we want to use the first iteration of our formula. So we're going to do sine C divided by 37.1 is equal to, the next thing we want to find is an angle and a side that are across from each other. So it's going to be sine B, which is sine 44. And the side that's straight across from it is this 29.5. Okay, so sine 44, we want to pair those two up, of course, because they're a set, so 29.5. Now again, all I need to do to isolate sine C is multiply 37.1 by both sides. Okay, so this is going to cancel out and I'm going to be left with sine C is equal to sine 44 times by 37.1 divided by 29.5. Now what you're going to end up with there is 0.8736. So does that seem like that would be a reasonable angle here? Well, hopefully you recognize that we're saying that sine of C is equal to this decimal, not angle C. So when we actually want to solve for the angle C, remember we're doing algebra to move this sine away and just isolate C. And so basically what we're doing there is saying C is equal to, we're dividing sine away, so we end up with the inverse of sine, -1, of 0.8376. And that is going to be equal to 60.88 something degrees. And so, like they mentioned, round to the nearest degree. Always pay attention to that in a test because you will be docked marks if you don't round properly. So nearest degree, if we round up from 60.88, it's going to be 61 degrees. Include our units, and there's our solution. Okay. So you guys have a chance to try this on your own. So if you want, you can pause the video. This one is going to be like that first one where we tried where you're going to have to sketch this out yourself. Don't worry too much about being exact the way I was if you don't want to, but make sure that you label and ensure that everything is across from each other properly. And then here's your answer down there so you can check that. Last question we're going to do is a word problem. So Joe is using chains attached to these hooks on his ceiling and a winch lift to lift up engines in his friend's garage. So the chains, the winch, and the ceiling are arranged as shown. We want to determine what the angles of the chains are. So 2 missing angles in this case. Now, as you probably remember with a triangle, all of the angles add up to 180 degrees. And so if we solve for one of these using Sine Law, for example, because this is not, we don't have any indication that any of these angles are 90 degrees. We're told this one is 86, which would be the closest one to being mistaken for a 90-degree angle. So we can use the Sine Law to solve for one unknown. Once we have that, we can just use the sum of angles in a triangle adding up to 180 to solve for the remaining one. So the first one we're going to do is Sine Law. It doesn't really matter which one you choose. Let me see on the filled in notes, what did I do? Because I'll do the opposite here. I solved for theta first, so let's solve for alpha first, just to show, like, if you check the filled in notes, you'll see a different way of solving it. So it gives you a little bit more understanding that these will all work no matter which angle you choose, as long as you have your properly identified pairs of sides and angles. So straight across from the given angle that we have, sine 86, let's see, we're going to be looking for an unknown angle. So I want to keep my angle on top for this use of the sine law. So sine 86 divided by the thing that pairs with it there is 2.8. Okay, that's going to be equal to, if we're looking for angle alpha here, so this is going to be sine alpha divided by, that's just, sorry guys, if you're not familiar, that's the Greek sign for alpha, or the letter A. So going straight across from there, we're going to have 1.9. Okay, so we want to make sure we use the correct side, not this 2.2. 1.9. And now it's just a matter of isolating, right? So to get this 1.9 away, we need to multiply it by both sides because it's being divided. So 1.9 and 1.9. Sorry guys, that's a little messy, but and so now these are going to cancel out, and I'm going to be left with sine of my alpha angle is going to be 1.9 times by sine 86 divided by 2.8. And again, we're going to get that weird kind of a decimal number where sine of alpha is going to be equal to, let's have a look here. So if you need to check how to do your order of operations, I'm going to put in 1.9 times by bracket. This is the important part here, is sine 86 bracket bracket. Enter that, and then I want to divide that by 2.8. So I get sine alpha is equal to 0.6769. And so if I want to actually solve for alpha, I need to do sine minus 1 of 0.676. Okay, so alpha is going to be second function sine of this angle, and that's going to be 42.6 degrees. So that's gonna, we'll round it up to 43, so we'll use whole angles here. So 43 degrees. And then, so now to solve for the remaining angle here, theta, we know that all angles added together are going to be 180. So if we subtract off the angles we know, 86 degrees and 43 degrees, we're going to end up with, let's see, 180 minus 86 minus 43 gives us 51 degrees. Okay, so then we would say theta is equal to 51 and alpha is equal to 43. Okay, now what you might notice here is that we have a little bit of a difference right in this first one, because I solved for the first one and I rounded that one up to 52. My alpha becomes rounded down. So if you have a difference of 1, just be aware that, like in a test, I'll be aware of the differences of those. You would only have this in a written question. Or if you had a multiple choice question, they wouldn't make you choose between like these two and these two, right? Because they can both be correct depending on in which order you solve it. Or you would have to round to the 10th of a degree, so then you'd be closer to being accurate. So don't worry about that difference there. It doesn't matter which side you solve first. I'll be able to account for that when I mark your tests. So that's everything for the sine law for today. You have some practice questions where you can kind of work with that information. And then next time we're going to extend on this, because we're going to look at something called the ambiguous case, which is where we get a little more complex, because it's when you have triangles that could exist in two different formations with the same side lengths. Okay, so we'll get into that next time. So I will see you then.